So my goal is I want to leverage the set driver set driven relationship to assist me in creating my exploded view. I have probably 50 different parts at least for my robot, and I think animating those all individually could get out of control pretty fast. And in the event that I make a mistake, or I want to redistribute the animation, the pace of the animation, I could find myself with lots of different variables to adjust. My goal is that I want to break my robot down into parts and be able to move one part and have that drive other parts in the equation. And this is pretty typical of creating any kind of animated character rig. It's pretty unusual that we're doing it for an exploded view, but I think you'll get the idea. What I want to do is I want to be able to grab, let's say, part of the lower arm and move that along the x-axis. And as I do, I want to explode the parts that are attached to it away from that piece. And so I'll just jump into a new document, and I have a relationship here established between the cube and the sphere, that the cube is the driver. And as I move that, it causes the sphere to move roughly twice as fast. Okay, so I can explode it in or out. And once I establish that basic relationship, I can have that cube drive several different parts, or I can even have the sphere itself drive additional parts. And so let me show you how I created this kind of relationship. I'll create a new document, and I'll start off with a cube and a sphere. And I'm going to have my cube drive my sphere. And so I'll select the cube, I'll find the coordinates tab inside the attribute manager, and I want to focus on the x-axis, or the red axis, and specifically the x position of the cube. So if I right click and I choose animation and I set that as the driver, I want to select the sphere and I want it to drive the x position of the sphere. So I'll right click on the x coordinate, I'll go to animation, and I'll set this as driven relative. It's important that we use relative. And right now, if I just test this and I grab the cube, well, first of all, let me back up. If you grab the sphere and try to move it on the x, you'll notice that when you set it as a driven, that x coordinate, I can't move it. I can move it along the y, I can move it along the z, but right now the x, the only way it's going to move is if it's driven by the cube. The cube x coordinate is the thing that drives the sphere x, and so right now, as I move the cube, it drives the sphere at a one-to-one relationship. So every one part that I move the cube, it moves the sphere one part. Now I can achieve that kind of relationship just by grouping these objects together and moving the group. But what I want to do is I want the cube to move, and I want the sphere to move twice as fast. And so in order to look at that, I'm just going to zero out the position coordinate for the cube. So right now my cube is at 0, 0, 0. In order to set up the relationship to have the cube drive the sphere faster than the cube is moving, I need to look at the expresso that we've generated. Now, anytime we set a driver and set driven, on the driven we get this little expresso tag that pops up. So in the object manager, if I double click on the expresso tag, what I get is I'm looking at the expresso editor. And right now I actually got a little bit of a glitch, and so I'm going to pause. For whatever reason, I'm not seeing what I anticipated seeing here, so let me try to rebuild this relationship really quickly. I think I bumped into just a small glitch, and so I'll select the cube. I'll right click on the X position, and I'll set that as driver. I'll go to the sphere. I'll select the X position, and I'll set that as driven relative, and I'll double click the expresso tag. This time around I got what I expected to see. Really don't have an explanation as to why I was only looking at one node, and maybe all the information was there but it was just stacked on top of each other. When I double click on the expresso, that takes us into the expresso editor, and expresso has a node-based editor. I don't want to take a deep dive into this, so we do take a closer look at this in the simulation class, but basically what we're looking at is we're looking at nodes that represent the relationship from one object to the other. And right now we're saying that the cube X position has an output, and it drives the sphere X position. And we know that that's the case, because if we take the cube and we move that around, not only do we set that relationship up, but we can see that being affected inside Cinema 4D. Now, we have a cube node here, and we have a sphere node, and I'm just clicking and dragging these. The cube has a position output, and it eventually feeds into the sphere input. And right now we have a one-to-one relationship. So for every one part that I move the cube, the sphere moves one part. Now, in between these two, the cube node and the sphere node, is this thing called a range mapper. And if I just single click on it and look down in the attributes manager, I'm getting the relationship. It's showing me the relationship at which the cube drives the sphere. The input lower and input upper right now is for every, it has a range of 0 to 100. And if I look at the output, it also is in a range of 100. It doesn't start at 0, but there's a range of 100 here. And what the input represents is, it represents the input of the cube. So in other words, the cube, I'll select the range mapper again. The input is the x position of the cube. The output is the x position of the sphere. And right now there's a one-to-one relationship. And so if I just modify the value of the output upper, let me add 100 to it. So I'll change it from 200 to 300. Right now what I've just done, if I move the cube, you'll see that it causes the sphere to move faster. What we're saying is that for every one part that we move the cube, we're causing the sphere to move two parts, because there's now a 200 part range. So we're 0 to 100 on the input, but we're having an output of what's effectively 0 to 200. The relative comes into play because if you look at this, if I go back to the cube, and I'll just zero out the position of the cube. If I look at the x-coordinate of the sphere, it has a starting value of 191. If I go to the range mapper, okay, I'm a little off here because when I applied, I must have moved the cube just a little bit when I was applying the espresso, but basically I'm really close to that 191 mark. I think I just accidentally nudged it. In your demo, your output lower will have the same starting coordinate as the x position of your driven object. Now here's the part where we take a deep breath and we remind ourselves not to be terrified of this new concept that we're looking at. It can feel a little abstract at first, but a lot of stuff does in 3D the first time we look at it. I will review this process as we push forward, but in a nutshell, what we've done is we've created two objects. We set one as the driver, one as the driven relative, okay? And then when we double click on this Espresso tag, that allows us to go into the Espresso editor, select the range mapper, and change the relationship of the input and the output, okay? And by doing so, that gives me this effect of being able to move the cube and have it cause the sphere to move twice as fast. And we'll leverage that concept and I'll apply it to my robot, and hopefully it'll save me. It'll be a little bit of work on the front end. It'll save me a lot of work when I start exploding my project. So we'll catch up in the next presentation.